stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leonard Facchinetti. Let's write some code together, shall we? What we have on the menu today is this thing behind me. We are continuing on this. Oh man, this is taking a lot more effort than I was expecting. So here's the story. We are working on this library to do real-time audio effects in REAPER. And one of the reasons why I wanted to do a library is to learn, but the second reason is that I wanted to have good visualization of what's happening to the audio. What is happening like over time on a compressor? What is the compressor doing to the waveform? And then this component that draws the waveform of the audio coming through is an essential part of that. Turns out that this component is slightly more interesting and complicated than I was expecting. So the topic of today's stream is, so you know how I am drawing the waveforms like this? I wanted to be able to also draw the contour around the waveform. So here on the edge, I would like to be able to draw that edge. And I tried to do that in a previous stream last week. It didn't work, because of the way that I am drawing the waveform. So I am collecting samples of audio as they come in. I'm looking at the maximum and the minimum sample in a certain block. And I'm calling this block a slice. And I'm collecting that over time, again and again and again. And then I draw these slices over here on the screen. The problem is that there are more slices than pixels on the screen. So effectively, the way that this drawing works is I draw one rectangle here over where my cursor is, and then I draw another one next to it, and I go from right to left. So my cursor is going to go from right to left. And then I draw another small rectangle, a very thin rectangle. And then I move on to the next one and I draw a very thin rectangle, and so on and so forth. The problem is that I'm doing that once for slice that I'm collecting. So as audio is coming through, I'm collecting those samples and coalescing them into slices. And then I'm drawing each and every slice that I collected, which means that if I have more slices than pixels, which is often the case, because I'm collecting like 8,000 slices on this drawing, and I don't have 8,000 pixels across my screen. So I'm drawing the same slice multiple times. And then if I try to draw a contour on top of that, it doesn't really work. And this also means that the slices have more ups and downs than what you can see here. This waveform looks like a solid red blob, but in fact, it's made of several thin rectangles, and some of them are taller than others. And that has two problems. The first is the contour thing that I mentioned. I wanted to be able to draw the contour of this red blob. And if I tried to do that with the naive approach I'm taking now, this contour actually dips inside the blob and comes back out as it's drawing the contour of each slice. The second issue is that this is not the most effective way of drawing on the screen, because I'm effectively painting and repainting the same pixel several times. I think that I'm painting and repainting a pixel 5 times at this point with the current settings. But the more slices I have, the more I would be painting the same pixels over and over. And I may want to have several slices in case I want to be able to zoom into the waveform to a certain extent. And hang on, I have to press a button here to pop up the chat. Great. And then I can take this screenshot out. And then Stalin Green is here. Hello, great to have you here. That would be a handy tool to monitor how effects affect the signal. That's exactly what I am planning on doing. I'm planning on developing like a compressor, and then I will show this waveform probably in this style, kind of going after what Pro C2 does, and also the compressor in Logic. They also show it like this. So there is that, but also I think it would be nice to just have an effect where you have like maybe something before and then something after, and then you put a compressor in the middle, and then you are able to see how the compressor is affecting the waveform for any compressor, not just for the compressors that have this kind of visualization like my compressor or Pro C2. So it's not as convenient as having the waveform on the same user interface, which means that you will have to open two screens side by side, and then you have to like change parameters here and look there. Also, there is already something that does something like that, but the routing for that thing to work is kind of weird. It's called the gain reduction scope. It comes with REAPER. It's a stock plugin. But the way that it works is kind of weird. The way that it works is you have to use pins. So you have to say that the original signal is coming in some pins, and that then the compressed signal is coming in other pins. So it's kind of annoying to use the reduction scope, and I think that we can do better. So it's always a trade-off. The trade-off is if you are using the gain reduction scope that comes with REAPER, you have to use pins and you have to route things in multi-track and multiple channels, not multiple tracks. You have to route things in multiple channels. It's kind of annoying to use. And then with this idea of making a sandwich of plugins, then you have to bring in two instances of the plugin, and you have to make them talk to each other, so they have to be in the same group. Yeah, so it's a whole story, but for our compressors, this will come out of the box, this kind of visualization. And Tail is here. Hello, Tail. How are you doing? It's great to have you here. Hope you enjoyed this session. You were here for the last one when I encountered this problem that I'm about to solve, hopefully. So now you follow along with the solution of the problem as well. And that's really the solution of both problems. So now I'm compressing, and the waveform here looks different. Looks compressed, I guess. I'll take this out. So yeah, see how it's different from here to here. So the solution for the problem, for both problems, the repainting as well as being able to draw the contour, is the same. The solution is, or at least one solution, that's the solution that I'm going for anyway. I'm going to do something similar to how I collect a lot of samples and then compact them into slices, because I don't store every sample that is going through here. I just take the maximum and the minimum of a certain slice of samples, and then I just store the maximum and the minimum for the slice. I'm going to do the same trick where I go over slices. So this time I'm not going to go over samples and collect slices. I'm going to go over slices and collect what I'm going to call, I guess, a pixel, or maybe a column. Probably a column. Yeah, I'll call it a column. So I will be going over slices, and remember, I have more slices than pixels across the screen. So I have more slices than columns. I'm going to go over the slices, collect the maximum and the minimum of all the slices, and then I'm going to draw a column on the screen. And Bo is here. Hello, Bo. Great to have you here. How are you doing? I'm doing well. I hope that you are too. Right, so that's the plan. We are going to effectively implement sort of a variation on the same algorithm, but there are different constraints here. Particularly, the constraint is that there is no notion of a half pixel. You cannot subdivide a pixel. Not unless you think about like using subpixels to draw stuff and anti-aliasing things, but let's not get into that. Let's just think about pixels as a box, a unit that I cannot subdivide. That means that I cannot do exactly the same trick. In the implementation of the waveform push, that's where I'm collecting samples to make up the slices. What I do is I have a circular counter here, and if I need to store like 3.5 samples per slice, I can collect sort of 3.5 samples, though samples cannot really be subdivided either. But what I can do is I can, like, if let's say I need 3.5 samples, I can collect samples 1, 2, and 3, and 4 on the first slice, but then collect only samples 5, 6, and 7 on the next slice. So the first slice will have 4 pixels, the second slice will have not pixels, samples. The first slice will have 4 samples, the second slice will have 3 samples. That adds up to 7. And you can pretend that each of these slices had 3.5 3.5 samples, and it would sort of work out the same. It would add up to 7 as well. So that's the code that we have here. But when drawing on the screen, there is no notion of a half pixel. At least I don't want to think about it that way. So I think that the implementation will sort of, it will not be exactly the same. It will not be a copy and paste. We'll see. And oh, I was going to ask about your brother, but I didn't want to like put you on the spot. But it's great to hear that he's doing better. And so let's dive into the function that is currently drawing the waveform. This function is what is drawing these colors here on the screen. So currently the approach is that I'm looping over all the slices and drawing. I'm going to change that. I'm going to first compute how many slices I will need for a column. And then I am going to loop over columns. I know how many columns I want. So I guess I'm going to start something. I'll start sketching something up here because I don't know exactly what variable names I will want to use, and maybe I will even change some of these variables. So start sketching something up here. The intent is how many colors, not colors, columns. How many columns do I want to have? That is the width of this drawing box. So I guess what I want to do is to loop over the width of this box. This width is given in pixels. And then I will have this notion of column that is going to start at, let's say, it's going to start at the end. For me, it always makes sense to draw from right to left because the most recent samples are on the right and the oldest samples are on the left. Maybe I could have an option to reverse this, but for now, that's what it looks like. And I think it makes more sense because that's how the timeline usually works. Future is on the right and past is on the left. So I tend to write code that draws from right to left. I think it just makes more sense that way. So that's why the column number is going to start on the right, which is, I guess it's not width, it's probably something like this. Because I have to take in account the x position of the whole component, the whole waveform component. So, and then this slice width, I guess I will have something that is not a slice width, but a column width, which is just 1 pixel. And I will have this as a variable because maybe I will want to change the width of the column to make things look better. We'll see. Maybe I will want to have this column as not 1, but as GFX x retina to take into account retina displays. But I think that if I just let the column width be 1, I will support retina displays with higher resolution. I will be showing potentially different columns, so potentially different parts of the waveform in every pixel of a retina display. So that's why I have the 1 here. Maybe I shouldn't even have 1 here. I do have a variable that is called space px. Oh, but that one takes in account x retina, so I will specifically not use that. So right now, the column is starting all the way to the right. So this x is the x coordinate of the whole waveform component. So I'll have the x here, plus the width of the whole component, plus the width of one column. And this plus the width of the whole column is just so, it's just a little trick so that I can do this. And then on the first iteration, I will be right at the last pixel that I want to draw on, or at the last column that I want to draw on. Now that I think of it, this is actually going to put me at the end of the component. So if my component ends right here, I may not want to have my cursor, right? Because this is a cursor effectively. It's moving to the left. I don't want to have my cursor at the end. I want to have my cursor at the end minus column width, which means that I don't want to add the column width here. It's just an off by 1 mistake, but I think it's a mistake. And then maybe the number of columns that I will have, it's not the width. As if I keep doing that, I am going to draw one off to the left. I don't know, it's an off by 1 thing, so I will not worry about it. So this is now looping over columns. That's different from looping over slices. Now I have to think about how I'm going to take the slices to make up the column. I guess I can quickly compute how many slices make up a column. Let's have a variable that is the number of columns. Columns. That is just the width for now. So that's a silly thing to do, but the reason why I did it, why I extracted this into columns, is so that the next formula will look a little bit better. So now I need to know how many slices per column. And I think that that's something similar to what we have in terms of when we are computing slices based on the samples, we probably have something that is like the maximum number of samples in slice. So it's not exactly the same. It's not named exactly the same. So see, that's why I said it wasn't exactly a copy and paste. How many slices do I have per column? Well, I need to look at the length of the sizes, of the slices. I need to know how many slices I have. So I guess at this point I can take this block and put up here. So what this block is doing is just getting a hold of some parts of the slices data structure. So now I have the number of slices. The number of slices divided by the number of columns gives me the number of slices per column. Great. So maybe I will have a new line here just to make this a paragraph. Do I tend to do that? I tend not to. Well, I guess I won't then. So now this is the place where I have to think about that issue of the half pixel situation. I think that a fair solution for this is to just not worry about it. If the slices per column is a fractional number, I would just round it down or round it up. Yeah, I think that that will do. So if I have 3.5 slices per column, I can just look at 3 slices or 4 slices, and that will do. Right, so now I guess I have to loop over the number of slices per column. So this is I'm nesting 2 loops, which is never a good thing. It's always expensive to loop. So nesting loops, even more expensive. But we are drawing things, so I think I can get by with doing this. We'll see. So now we'll have this notion of slice maximum and minimum. We'll have a notion of column maximum and column minimum. And then we'll loop over the number of slices per column. And I guess I will do this so that if I need 3.5 slices per column, I will loop over 4 slices, which means that the same slice may show up in 2 adjacent columns, but I'm okay with that. So I will need to start this somehow, start the maximum and the minimum somehow. I do know how to do that though, because I have done that in the past. I just need to use infinity. So the maximum is going to start at minus infinity, and the minimum is going to start at infinity. Then in this loop, it's still not completely set up. The loop is still not completely set up. I will need some variable here. But let's just do the part. I will need to have some variable to know in which iteration I am. But let's just go over here and do this, which is the part that I know how to write. So what I want is to take the maximum and over here, the minimum between the current maximum and minimum respectively, and the slice maximum and minimum. You may be thinking, well, what is the slice maximum and minimum? That's the part that we need to collect next. So we are looping over some slices. What are exactly we looping over? Well, I suppose we will be able to borrow some stuff from down here. Oh, and we probably want to clip this. But we can clip at the end. And we will want to scale it as well. So I guess at the end, I will want to say something like, take the column maximum and minimum, multiply by the scale, and then clip the result to 1. Just like we did here. And this scaling is so that you can zoom in like this. And the clipping is so that if the thing is so large that it goes over, so I guess I can reproduce this by putting recomp before and make it very loud. Just want to double check that this is not going into this stream. It doesn't seem to be. Great. So if I make it like recomp, compress, and output at -24, then this waveform is clipping, as you can see here. And that's what the clip thing was preventing. And surprisingly, bigger values make the code slower. Doesn't make a lot of sense, but it seems to be that way. So now we took care of the clipping. We do need to take care of getting a hold of the slices. And I will need to have some sort of offset variable here. Before, the offset was rather straightforward because I was just looping over all the slices, but now I need to know at which point I am. So my offset is going to be slightly more contrived. This offset is into the circular buffer that contains all the samples. So I think that the offset needs to be well, another thing that I'm just realizing now is that we do have this slices in a circular buffer. And yesterday with Arya over here on the stream, we implemented the notion of linear interpolation. So we could just linearly interpolate between the values and get offsets that are fractional. That could smooth things out. And it will make the drawing a little bit slower too. And then this notion of just taking the ceiling does not quite work. Yeah, so I won't. I will not do linear interpolation between the slices. Let's just continue with this idea of calculating the offset. So where am I? It's based on the column. So maybe I can use the offset over here. And the offset, I suppose, can start at 1, just like it was before. And then in here, maybe I will call this something else, like the offset of the column. And this number is slices per column. It seems like I always want to take its ceiling. So do I want to do the ceiling here? I guess. Okay. And I think I'm going to change something else about this. This column is this column variable, not the column dot something, just the bare column variable, seems to be giving me the x position of that column. So I will give it a proper classification here, column dot x. And that seems about right. Yeah. And then this offset situation. Well, the slices per column, I don't need to do like this. Or no, I just realized that I will want, in about a minute, to have the fractional version. So I'll take the ceiling here, because I will want this to be a fractional value in a moment, because I will be multiplying by this guy in a moment, and I want to take in account the fractional part of it, I think. We'll see. So this still stands. This, I think I want to change. Maybe I want to compute it here. And there is no really there is no real reason for me to take the ceiling here. I could just take the ceiling there. So slices per column ceiling. Or maybe I'm not sure I want to commit to a ceiling. I may want to do floor later. So I'll just say integer. And this is saving the computation of the ceiling inside the loop. Doesn't really matter. All of this seems to check out so far. So now I need to think about how to compute this offset, because eventually I will want to do something like this. Well, I guess I can copy the whole column to get a hold of this slice. But I do need to compute this offset. So I know that I want to compute my offset, which will be something that I still don't know how to do. But then I do know that I will want to take this offset and just keep subtracting 1. So I do know that I, to begin with, will want to add 1 to that. And then I'm going to take the offset and go to the left on this circular buffer. The left is the pass into the circular buffer. So far so good. I guess I'm only missing this formula. The formula seems to be the number of slices per column times, I guess, the column index, which is going to start at 0. So this is going to count from right to left. It's going to start at, not 0, at -1. And just like that. And I better do index first, x second. So it starts at 0 effectively, because I will be adding 1 right in the beginning on the setup of the loop. So I will be at 0 and 1 and 2 and 3 and so forth. So I'm counting columns from right to left, which means that I can just take this column index here. So to begin with, it will be 0, and we'll be multiplying by 0, which means that the offset will be 1, and then we will subtract 1, which means that we'll start at offset 0. Next time we go around, we will be in some fraction. Oh, this can be a fractional value. So I do need to take, I suppose, the floor of this value, I want to say. I'm not really sure. This will be a fractional value because this is a fractional value. And that's why I wanted to have this as a fraction to begin with, so that I can take in account the column index based on the number of slices per column as a fraction. Ah, yikes. Okay. Now, this is going, I think, to put the variables in the right place. The column maximum and minimum will be in the right place. So after this loop and this postfix thing, I am ready to draw. So let's find the part of the code that does drawing. First of all, there are these measurements that I think still make sense. So I will paste them here. I will accept that it's not the slice width. Now it's the column width, and I do have a variable for that. But half of the height still makes sense. The drawing width still makes sense. Well, not quite, because I will be using column width for that. Yeah, but the Y midpoint still makes sense. I hope. The offset we just computed, the draw X now is the column X. Then this is looping over slices, which we no longer need to. Then this is manipulating the offset. This has to do with the draw X, which I already took care of. All of this grabbing stuff from the circle above for scaling, clipping, we took care of all of that. Oh, and there is also this part, which we did not take in account, which is this notion of taking the square root of the columns now. And this is the difference between the red and the blue waveforms. The red waveform is not taking the square root, the blue waveform is taking the square root. And then, oh, there is this notion of rectifying stuff. So I guess at this point, this is mostly the drawing, so I will copy all of this over. But I will have to change a bunch of variables. The draw height, is that still a thing? Well, I guess I am now calling it the column. So everything that is draw dot probably can be replaced with column dot. Hopefully. Right, so let's read over this. What is the column height? It's the maximum of the slices. Well, I guess every place where I have a slice, I will probably want to have column. Right, so what is the height of the column? It's when I'm drawing the rectified peaks, these are the ones over here at the bottom. So the height is the maximum of the maximum between these two numbers, and they have already been clipped, so that's okay. Then you just take the absolute value of them and multiply by the height. And then what is the y? The y is the y of the whole component plus the height of the component minus the height of the column. All of that checks out. Then for the non-rectified peaks, so this over here, the top is the y midpoint minus half of the height multiplied by the column maximum. The bottom is about the same except multiplied by the minimum. Y is the top. Height is the bottom minus the top. All of that checks out. And if the height is less than 1 pixel, well, I don't think it should be 1 pixel. I think it should be column width. And I'm now checking if all of these are integers. They should be. But no, this will not be an integer, because this is taking these values and multiplying by another thing, but they are not guaranteed to be integers. So just take the ceiling of that. Then this is guaranteed to be an integer. The midpoint may not be an integer. So I'll take the floor of this. And I don't think that JSFX really care if I am passing fractional values to drawing the rectangle. It's just going to take the ceiling or the floor, but it does make sense to reason about this, so I will. And then the column maximum is less than 1, and the column minimum is greater than -1. Oh, okay, so I don't want to draw anything if I am clipping. But hanging there, I'm already clipping here. So how is that going to help? Because these values are guaranteed to be in the boundaries anyway. I think that this code was written before I did the clipping, because I don't think this is relevant anymore. The maximum and the minimum are guaranteed to be between -1 and 1 because of the clipping. So why bother checking this? And then this really boils down to, which may not be the best way of writing it, but I will. I guess I can just take the maximum between the column width and this computation. Then I have the whole thing in a single line. Good. So if I am filling in the waveform, which means that I passed a color to do this, I set that color and I draw a rectangle in this position. And if all the rest of the formulas are correct, then this will be correct. And then here I have something to disable drawing the stroke, but now I will not do that. Then the column height is equal to the column width, which is just a single pixel. That may be too small. So maybe I want to have a stroke width sort of situation going here. But for now, I will just fix a value here. I will say that the stroke width is always, or maybe I won't. I will do a proper thing here. So I have the colors, and then I will have a stroke width. Well, I don't like how these are reversed. Yeah, maybe I will change this variable name to be fill color. Then stroke color. And then stroke width makes more sense in that context. So now I can just take this guy, paste it there. And this is not really going to change. So why do I bother? Oh, because I had to change this up here. So yeah, okay, that makes sense. And then stroke color, and then top and bottom like that. Okay, I think that all of this makes sense. So now let's go over all my local variables, put them here, and we'll give this a try. So all of these are new local variables. Oh, I probably want to get the equal signs. Then this has already occurred, this has already occurred, but these are new. I really wish that local was the default and that global I had to specify. Then these are new. And then these I have already defined. This I have already defined. This is probably new, and this is probably new as well. And they repeat down here, so I guess this is also new, and that's also new. So I might as well just copy them from here. Then that's it. All right, we can try this, but it's probably not going to work because we changed the parameters here. Do we have another flavor of drawing? No, but we do need to take into account the stroke width now. So let's go to the place where we are calling the function. And we have 4 calls to the function. Because we have the squared and the square root, the not square root, the rectified, not rectified. We have all 4 flavors. So we have 4 function calls, and we need to look into the place where we are passing the second color. And we need to pass this stroke width there. It will be space of like maybe 1. Probably that will do. Or maybe I think I have a stroke width primitive. So stroke width of like 4, let's say. That looks good. Now let's go over this code one more time before we actually try this, because this I think has a very small chance of actually working first try. So let's review the code to see if everything makes sense. So here I'm just collecting pieces of the slices that I will need. And that was working before, so I don't need to worry about that too much. Then half of the height seems okay. Could be multiplying by half instead of dividing by 2. Doesn't matter. Then the y midpoint is just the floor of the... Okay. Maybe I should have a floor here instead. Yeah, I think I will do that. Because this is going to be used in other situations. Where it could come in handy the fact that this is going to be an integer. Oh, and these guys, I'll take the floor of this one and the ceiling of that one. Because this is a fraction, so this will be a fractional value as well. And I'm taking the floor of the top and the ceiling of the bottom so that they are in bounds. And now that I'm doing that, it doesn't matter if the y midpoint is fractional. So I can let this be a fraction. I can let that be a fraction. Oh, you know what? Unrelated thing, but I just realized something. Yesterday we were working on interpolation, and I made something silly here, where I take the absolute value of this subtraction. I could just inverse the order of the operators, the operands, like this. And if I am right, I will be able to load the tests and they will still be passing. They are. That simplifies the code a little. That was bugging me yesterday. After the stream, I was like, oh man, I need to fix that. I'm glad that I remembered it. Right, so all of this still makes sense. The number of columns is going to be the number of pixels. Then the number of slices per column is the number of slices divided by the number of columns. That as an integer is used in a single place, but whatever. I'm computing it in a loop, so I might as well just have it as a variable. Then the width of a column is always 1. I'm going to start counting columns, and I'm going to start traversing this figure from right to left. And okay. Okay, all of that checks out. Then I'm starting to collect the column maximum and minimum, looping over the slices. To begin with, it's minus infinity because I'm going to take the maximum, and plus infinity because I'm going to take the minimum. Then the offset where I want to be is the slices per column times the index, because I'm counting from right to left. Oh, and this number needs to be negative, doesn't it? Because slices per column is a positive number, and the index I am counting from 0 upwards. And the index is only used here, so I could have this as maybe a column offset variable instead of an index. The column offset is going to start at +1, and I'm going to subtract 1. So now this is going to go over the columns 0, -1, -2, and so forth. So this is going to be negative. And then this +1 is just because I'm going to set up a loop again to go even further to the left. Okay. See, this right here, this flipped sign is the kind of thing that would not work first try. Then I take the slice maximum and minimum based on the offset I just computed. And I will break the lines like this. Then I will take the maximum and the minimum between the column and the slice that I'm going over. Then I'm going to scale and clip. And then, well, okay, I will do it like this. I was thinking of having the scale in one line and the clipping in another, but I might as well just do it in one line. I mean, I was thinking of separating this into its own line, but I don't think it's worth it. Then if I need the square root of the values, I will take the square root of them, multiply by the sign, just so I keep the sign, but I cannot take the square root of negative numbers. Is there a smarter way of doing this? I don't think there is. Then for rectified peaks, the column height, this part I'm more confident about because most of this I copy and pasted, but still, let's go over it. Just take the ceiling, because I want the number to be an integer. Maybe I'll take the floor because I don't want it to overflow. Oh, but it's times the height, so it's not going to. I can take the ceiling. At most, it will fill in the whole widget. Then just taking the maximum between the rectified values, the absolute values, multiplying by the height. And then the Y position sounds about right. The top will be the floor of this value. Sounds good. The ceiling of that value sounds good. Column height. This didn't change. Or actually did. So it seems like I will always be drawing something. Yeah, I may not always want to draw something, so that's something to check actually. Last time we checked with a DC offset. I think we can do that again. Then I just use the variables and draw. All right, so this stands a chance of working. Let's give it a try. And yeah, it's doing something. Let's look at this one at a time, because there is just too much on the screen. But I'm happy that this is drawing anything. Because, I mean, we changed a lot of code. Check this out. We wrote all of this today, so in less than an hour. So the fact that it's even drawing anything is remarkable. So let's do this first one, which I suppose is going to be the red one. No, it's the blue. The blue? I am surprised. Because the blue is not rectified, but it is square root. Okay, I will want to reorder. No, I don't want to reorder this because the order impacts the result. I wanted to draw the blue first. So I will comment out the blue. I'm going to go with the red because the red is the most vanilla thing. It doesn't rectify, it doesn't take the square root. Let's look at that one. Okay, it is drawing and it is taking the contour all right, and it kind of looks okay. It flickers a little bit. But it is drawing something. And it does seem to draw a contour. I want the contour to be... So this is the contour. So the contour is brighter. That's okay. And maybe a stroke width of 4 was too heavy. Let's do a stroke width of 1. Hello. And okay, this is looking nice actually. It's a waveform and it has some depth to it because of the stroke color. The brighter red on top makes it pop off of the screen. So this is not terribly bad. But there are some glitches, so maybe we can increase the column width. So see, it's kind of nice that I gave this a variable. And I don't think it needs to be available to the user, but it is nice that we have this as a variable the whole time. So now I can just increase this, and I can do a space of a pixel. And bring it back. And yeah, I am happy with this. This doesn't look bad. There are some glitches, like here, there are some spikes that you wouldn't really expect to see. And if I made this column width even bigger, then I think I would not see them. So let's go one up. And I guess we are back to where we started, but so now let's look at this. And it's looking okay. Kind of still has that effect. And it gives me the impression that it's moving along faster as I'm increasing this number. Isn't it moving along faster? How do I make this? I can change the variable in the library, I suppose. But I don't know if it will be picked up immediately. Let's try. Also, it's glitching more now. But this is looking great, actually. If I make it full screen, it doesn't look all that nice. But if I make it smaller, it does look great. Oh, I mean, look at this. This is wonderful. Except that it's glitching, probably because of the nested loops and everything. But this doesn't look too bad. This is the kind of thing that I want to be able to draw. Yeah, so let's put this to bed for now. I will leave this as it is. But let's investigate the issue. Let's bring back the other ones, because there were some glitches in the middle of the screen, so let's fix that. So now we should see the blue behind the red. And the blue behind the red is not the reason for the glitches. And it also kind of looks okay. I guess it looks like what I wanted it to look like. I'm happy with that. Then let's look at the rectified with no square roots. So it's this one. Remove and re-add. And then we have the rectifieds, but oh, okay, so bringing in the contour is making this thing happen here at the top. So it's the contour of the purple that is glitching out. Let's look at this. What do I have in column top if I am rectified? Oh, check this out. If I am rectified, column top does not exist. And does this even make sense? Hanging there. Why would I want to draw two rectangles for the rectified version. I don't want to draw 2 rectangles for the rectified version. I only want to draw 1. So I will need to check if I am rectified or not when drawing the contours. At that point, I think it makes more sense for me to copy and paste this code because the reason why the code looked like that was to don't repeat yourself, but it seems like we are about to do different things, so it might as well just repeat ourselves. And alternatively, I could just check again if I am on the rectified version or not when drawing, but I think I prefer to do it like this, because now I'm grouping the logic for rectification all in one place. And if you're thinking about rectification, you're thinking about different formulas and everything. So that makes more sense to me. So what I have to do is do this. And hang on, this column height situation, does it make sense over here? Yes. And yeah, it seems like what I want to do is to draw a rectangle at the column Y. What is column Y? I think I want to draw a column Y, exactly. And I don't want to have the column height. I just want to have the stroke width. Where am I using stroke width? As I will change it here, makes more sense this way to me. Okay, let's watch what happens now. Okay, it's no longer glitching in the middle, and I do see a different shade of purple at the top. The contour is being drawn correctly. Great. Let's look at the final one. But I'm confident that if the other one works, this is going to work as well, but still. Because it's just a square root difference. Yep, there you go. We have well, I guess the title of the stream, economic drawing. We are not drawing over the same pixel twice. And we have the contours as promised. Now, is this like the best looking thing ever? I don't know. I don't think so. If it's smaller, it does look better. If it's like this, it's kind of okay. It's glitching a whole lot. Let's commit what we have and play around with the width of the column to see if that helps. Let me see if I like what I'm looking at. I think I actually do. I think that this makes a lot of sense. Okay. So first, let's investigate this issue of the column width affecting the speed. How many columns do I have? It's not the case that the number of columns is the width of the component. It's not that. I will need to define the column width before, and the number of columns is the width of the component divided by the column width. That's the number of columns that I have. Then this can be a fractional value. So do I take the floor or the ceiling of this? I guess the floor, it doesn't really matter all that much. It's an off by one thing, but I think that will do. So now it should be moving more slowly on the screen. And it seems to be. It's moving more slowly now. And it's still like flickering. It's glitching. So that's not great. But I think it's moving as it should. Now it's not. I think I know what that is, but it's the width of the cells of the columns here don't affect the speed anymore. And we can play around with different widths, but you know, I think that the thing to fix is this flickering, this glitching on and off. And does it go away if I don't draw the contours? So everywhere where I have, I guess, 500, I will do a little trick where I comment out this line and pass undefined instead. That will make the contours go away. Does this look better? Nope, still glitching in the same way. And it wasn't glitching like this before today, before we started this session. So I think I know why that might be, which means that we will need another session of drawing freaking waveforms. This was supposed to be so simple, but still here we are. Right, so the contours are all right. We are drawing more economically. I'll call this a success for today. Next time, we'll need to deal with this flickering. And I guess this flickering has all to do with the fractional pixels, so to speak. Maybe I can, is there a quick fix for this? Let's give this 1 or 2 minutes to see if we can fix it. If the number of slices per column is an integer, I think this may not glitch anymore. Hello? No, it's glitching all the same. You can sort of see the thing going up and down. So that there is no easy fix for this. The issue is that maybe this approach I'm taking is flawed. The issue is probably that the column is sliding over a small window of slices. As it does that, it picks up different maximums and minimums from different slices as it's moving along. Is there anything I can do about this? This part moving forward, not this formula, but this part here and all of this, I don't think there is anything I can do about it. Yikes. No, there is no easy win on this one. Oh, and there is also a glitch here on the left. Check this out. This seems to be getting stuff from the right. So it seems like we are wrapping around in the circular buffer. Oh boy. Was this here the whole time? I don't remember seeing it here. Fun stuff. Okay, I committed what I had. Tomorrow, I am taking the day off. on Thursday, we'll get back to this drawing waveforms and try to solve these glitches here on the left and solve the flickering. I will think about what could be going wrong here. And we'll meet again on Thursday for more of this. Thanks for being here, for watching this, for supporting me on PayPal and Patreon, and these days even Bitcoin. You can send me Bitcoin if you want. More information about that in the link below for my website. You can just go there and you'll see all of these links. And thanks Stalin Green and Tail and Bo for being here, for joining me on this session. I hope you enjoyed this. I see you again on Thursday. Have a good one. Bye.